Mario Capecchi was one of the three scientists who were awarded the Nobel Prize in Physiology or Medicine in 2007 for their discoveries of principles for introducing specific gene modifications in mice by the use of embryonic stem cells. However, him winning the most prestigious prize in science was not the most impressive thing he did in his life. For reference, in terms of level of difficulty, it is somewhere above winning a Nobel Prize and below surviving academic politics. He overcame abject poverty and homelessness as a child, with his earliest memory of his mother being arrested by the Nazis, and became a well-rounded and kind scientist and person. Hello, curious cats, and welcome to Choosing Science. Oh, as a quick update, long time no see, I finished my PhD, changed countries, found another job, academic life. But now I'm back, and I wanted to tell you about the life of Mario Capecchi, a very inspirational life story. And everything started on the 6th of October of 1937 in Verona, Italy, when he was born. He came in this world during a very tumultuous historical time, akin to his parents' love affair, Lucy Ramberg and Luciano Capecchi. Fascism, Nazism, and communism, and all the isms in the world, threw the world in the political instability which boiled over in the Second World War. In this political climate, Lucy, a poet who was part of the Bohemians, met Luciano, an officer in the Italian force. Despite becoming pregnant with Mario, Lucy decided not to marry Luciano, which determined him to basically go for milk and never come back. Lucy then moved to Tyrol in the Italian Alps until Mario was 3 years old, and until the spring of 1941 when his whole world was torn apart. Because of her affiliation with the Bohemians, who were against fascism and Nazism, Lucy was arrested and then sent to presumably the Dachau concentration camp. However, she anticipated this happening and sold most of her possessions and gave the money to a family in Tyrol to take care of little Mario. She would be reunited with Mario 5 years later, but both were being left with psychological scars that will follow them forever. In the beginning, Mario's time on the farm of his new family wasn't so bad. He spent time mostly with the women and children on the farm and participated in their activities and simple life. But within a year, the funds left by his mother ran out when he was around 4 years old. From then on, he recalls in his autobiography, I quote, that he was living in the streets, sometimes joining gangs of other homeless children, sometimes living in orphanages, and most of the time being hungry, end quote. This unfortunate state of being lasted for 4 more years, but more tragic perhaps is that actually his dad came back from his milk errand during this time and attempted to take Mario to live with him in Reggio Emilia for a total of 3 weeks, but was so abusive that little Mario preferred the streets. Heartbreakingly, he writes, I quote, "Amidst all the horrors of war, perhaps the most difficult for me to accept as a child was having a father who was brutal to me," end quote. Maybe his dad should have left to buy a pack of cigarettes instead, and maybe he would have stayed gone forever. But I digress. Finally, in the spring of 1945, Lucy was liberated from the camp and set out to find little Mario. It took her more than a year to only find him in a hospital with other ailing and orphaned children. He was suffering from typhoid fever and malnourishment. She took him away from there, and with the financial help of her younger brother, Edward, who was living in the US, she managed to buy 2 boat tickets to America. Mario's horizons suddenly opened up. His uncle Edward was a brilliant physicist who contributed to electron optics and black and white and color television. Him and his wife were Quakers, which, no, it's not offensive as I first thought. Well, it's kind of, but I'll get to it in a moment. But it describes the members of the Religious Society of Friends, a Christian movement ascribed to radical peace, founded by George Fox around 1650. The name comes from the fact that George Fox told the judge to quake before the authority of God, after the judge told him to quake before the authority of his court. And to quake means to tremble. And after this sassy reply, it made the critics call them Quakers. And instead of being offended, they took it as a sign of pride, and they stayed with the name until now. So, following the logic of haters gonna hate, the followers of this religion ended up owning the term and using it to describe themselves till this day. So Taylor Swift and probably Jesus would be proud, that's all I can say. In this accepting community, Mario came in contact with loving and supportive people who taught him many things he didn't get to experience in his tragic and short life so far, like painting, dancing, and communal work. He said, I quote, "Time was needed for healing and for erasing the images of war from my mind," end quote. He was sent to school almost immediately, and despite not knowing English or even how to read or write at all, he slowly managed to integrate and thrive academically. In high school, he initially attempted to major in political sciences, but as he himself admitted, it contained little of an actual science, and eventually he switched to mathematics and classical physics. But he grew dissatisfied with the state of these sciences as they required big scientific working groups, and he was longing for a more individual, hands-on approach. Therefore, he embarked on lab rotations all over the country and ended up at the Massachusetts Institute of Technology, MIT. Here he became enamored with a new and shiny discipline, which was molecular biology. This field was a virgin scientific ground at the time and was promising to uncover basic principles and phenomena which governed all living beings. When looking for a place to start his undergraduate studies afterwards, he looked towards the most promising place at the time, Harvard. He landed an interview with Professor James Dean Watson, yes, that Watson, who, when asked by Mario where he should do his undergrad studies, he replied, I quote, "Here, you would be fucking crazy to go anywhere else," end quote. If my potential supervisor would tell me that, I would probably be compelled to study anything with them, even if it was the art of pouring air into a glass. What can I say? I'm a simple gal. So Watson was a pivotal influence on Mario, and I'm taking this moment to point out how important a good and honest mentor is for one's career. I would argue that this is more important than the subject itself sometimes, as you can fall in love with many complex and enticing scientific endeavors, but only a compassionate and generous mentor can inspire you to reach your full potential. As an example of that, Watson told Mario when he was considering leaving Harvard as a faculty member to go instead to Utah that he would do good science anywhere. And if that is not a compliment, I don't know what is. He described his time in Watson's lab as being a tremendous experience, trying to crack the code of how proteins were encoded and synthesized. What was nice to find out was that from Mario's account, Watson was always quick to recognize the student's contribution, despite being merciless and very exigent at times. This is a very important point to highlight, as there is still a running issue in academic research in getting true recognition of one's effort as a student. He then moved to Utah University, where he stayed for the rest of his career. Now, let's talk about his groundbreaking discovery, but first, as always, it's time for the question of the episode to get your curiosity going. So, this is the one for today. Which bacterial defense system discovered in yogurt making microbes inspired the CRISPR-Cas9 gene editing tool built on Capecchi's genes targeting principles? Go and search. Okay, now let's go back to the science. But first, we need to get over some of the important principles so it's easier to understand. If I'm telling you something that you already know, maybe just skip it, or maybe it's a good refresher for you as well. So, imagine DNA is a massive instruction manual for building and running a living organism. That's what we all know. Each of the genes in the DNA is like a specific instruction telling the body how to make something, like a protein that helps with digestion or fighting disease. Before Capecchi's work, scientists could study genes but couldn't precisely turn off or change a single gene to see what it does because they're all close together and they couldn't just target one. So Capecchi developed a way to edit this instruction manual in living mice. His technique, called gene targeting, lets scientists target a specific gene, knock it out, aka disabling it, or replace it with a modified version. By doing this in mice, researchers can observe what happens when that gene is missing or altered, helping them understand its role in health, disease, or development. For example, if a gene is suspected to cause a disease, scientists can knock it out in a mouse and see if the disease disappears or changes, and then you kind of have a clue about how to treat it in humans. So think of it like troubleshooting a car. If you remove one part, like the battery, and the car doesn't start, you know that's the battery's role. So Capecchi's method gives scientists a tool to do this with genes, making it possible to study diseases like cancer, diabetes, or genetic disorders in a precise way. What his work relies on is a natural process called homologous recombination, which is a mouthful, especially if English is not your first language, which he harnessed to make precise genetic changes. So here are the key principles and steps involved. This homologous recombination is the way the cells have their natural ability to repair damaged DNA. When DNA breaks, the cell can use a similar homologous piece of DNA as a template to fix it. Capecchi used this process to swap a specific gene in a mouse's DNA with a modified version. Then what he used are embryonic stem cells, as I mentioned before. These embryonic stem cells are special because they can develop into any cell type in the body. And by modifying the DNA in these cells, he could create mice with the altered gene in every cell of their body. And then you can have a mouse line that you can use forever and has that gene modified in all the generations that follow. And the way he did this was to modify these embryonic stem cells by injecting this modified gene, or this modified embryonic stem cells rather, into the early stage mouse embryos. And these embryos were implanted into a surrogate mother mouse, which then gave birth to offspring carrying the modified gene. As I said, the generations that followed, they all carried this modified gene. And to make sure that the modified cells were selected properly, Capecchi's, and nowadays also, you can include a marker gene in the lab-made DNA. So for example, a marker might make cells resistant to a specific drug. So when you apply that drug and the only cells that remain, you can conclude from that they're the cells that also have your modified gene. Because they're the only ones who survived. And the key to Capecchi's success was the precision of this homologous recombination, because unlike random DNA changes, his method targeted exact genes, ensuring the changes were specific and controlled. So, by 1987, Capecchi successfully modified a gene in the mouse embryonic stem cells, and he inserted those cells into a blastocyst, or the early stages of the embryo, and produced mice with the targeted gene altered. This technique, called gene targeted, as I said before, allowed scientists to study gene functions, and you can see the effects of their absence or modification. He collaborated with Oliver Smithis and Martin Evans, who contributed expertise in embryonic stem cells. And in 2007, as I said before, the trio received the Nobel Prize for their discoveries in gene modification. Capecchi's journey from a challenging childhood in wartime Italy to a pioneering scientist underscores his determination and curiosity, and gave us this great tool that basically changed the world and changed science as we know it. Gene targeted has significant implications. By creating these knockout mice with specific genes, disabled researchers can investigate, again, roles of genes in health and disease and how they contribute to all kinds of ailments. And over 90% of mouse genes have been studied using this method. While gene targeting is less precise than modern tool like CRISPR that we have heard about lately, it did lay the foundation for advances in gene editing, gene therapy, and personalized medicine. So Capecchi's work has left a lasting impact on science, as one can imagine. His gene targeting technique has been used in thousands of studies, enabling researchers to explore the function of nearly all mouse genes. It also inspires advancements like induced pluripotent stem cells developed by Shinya Yamanaka. There's one episode, not specifically on them, but on him, but on someone that also was crucial to exploring and discovering pluripotent stem cells, which is actually the first episode I ever did, and what inspired me to start this podcast. So if you are curious, just go to the first one and listen. It's about Sir Gurdon. And coming back to the topic of the day, this allowed scientists to study cells without using embryos, which is very controversial. It was and still is, and it comes with a lot of ethical problems. And additionally, Capecchi's methods paved the way for CRISPR, as I said, a more efficient gene editing tool. His contribution extends beyond the lab, as his perseverance, rising from a difficult childhood marked by poverty and displacement, demonstrates the power of curiosity and resilience. In interviews, Capecchi has emphasized that science is about seeking truth, a principle that guided his career. He continues to mentor students at the University of Utah, even now. Yes, he's still very much alive, fostering the next generation of researchers. Also, on a personal note, which was very cute to read, he was reunited with his long-lost half-sister, who thought that both him and their mother died during the war. She heard about him, actually, again, only after he won the Nobel Prize, and obviously he got into all the news all over the globe. And then they got reunited, thanks to that. So, who needs a DNA test to reunite you with a lost or unknown relative when you can win a Nobel Prize? Am I right? So, as a conclusion of today's episode, I hope you found it also inspirational, because sometimes life just happens, and it's not just going to the lab, doing your job, finding something, go back home. No, life happens, and sometimes it can be very difficult and overwhelming, but you can still overcome it with a bit of luck, obviously, but also with a lot of resilience. And Mario Capecchi's journey from hardship to groundbreaking scientist highlights the impact of dedication and innovation in molecular biology, and probably in general as well. His gene targeting discovery reshaped how we study genes and their roles in life. And I think we should all think about, maybe sit with ourselves and think about the good and the bad in our lives, and the moments we had a bit of luck, a bit of fortune, and be happy about it. And when we are in a more trying time, maybe remember that life can and will always change, and not always for the worse. Sometimes it does change for the better, and then you'll have something to look in your life and realize that, you know what, maybe it was worth it in the end. So Stay tuned for more stories of perseverance and discovery in science. And I'll see you next time. Bye!